Hey guys, so in this lesson we will be able to determine what type of function is represented by a sequence, and we'll be able to use constant differences in ratios to state whether a sequence is linear, exponential, or quadratic. So this video is based off of a worksheet that is posted to you on Canvas for you to complete. You can either print it out or you can complete it using Google Docs. So we're just going to go through it. So using a table to compare types of functions. The first thing is talking about just recalling some information that we did back in units 1 and 2. And you're just going to fill in the blanks here with those words from that words bank that I left at the top. So arithmetic sequences have a common difference. We remember that they had a common difference. And that geometric sequences have a common ratio. Arithmetic sequences will add to get from term to term. And remember that we could also subtract, but that's the same as adding a negative. So we can just say add. And then geometric sequences will multiply to get from term to term. And again, you could be dividing, but we always talked about it in terms of multiplying. So you would multiply by a half instead of dividing by 2. Arithmetic sequences were also known as linear functions. And when we graphed them, they formed a line. So they looked something like this or like this. Geometric sequences were known as exponential functions. And when they graphed, they formed a curve. That doesn't make sense. They made a curve. And so they either looked like this or they looked like that. So they curved. And just remember that both arithmetic and geometric sequences will always increase or decrease. So what we mean there is that they don't do both. They can either always be going up or they're always going down. They don't do both. And that's a distinctive difference to what the next function is going to look like when we get there. So looking at these first examples, you want to determine whether each table has a common difference, a common ratio, or neither. Then you're going to state whether it's linear, exponential, and why. So I've done the first 3, so you see what I want you to do. So for example 1 here, 3, 7, 11, 15. Remember that n is your term number, f of n is your term. So the term numbers will always start at 1 and go 1, 2, 3, 4, blah, blah, blah. And then f of n is your term numbers, the actual terms, so they come from your sequence above. We can see that to get from 3 to 7, we add 4. And to get from 7 to 11, we add 4. To get from 11 to 15, we add 4. So we can say that this sequence is linear because it has a common difference of 4. In example 2, same thing, fill in our term number, fill in the terms. We see that to get from 2 to 6, we multiply by 3. To get from 6 to 18, we also multiply by 3. And 18 to 54, we multiply by 3. So we know that that sequence is exponential because that is a common ratio of 3. Remember that if you have trouble seeing what the common difference or ratio is, like for number 1, you can always do, well, what is 7 minus 3? And that is 4. And what is 11 minus 7? Well, that is 4. And 15 minus 11 is 4. In example 2, you see that 6 minus 2 is 4, but 18 minus 6 is not 4. So we know that doesn't work. But if we look, we can do 6 divided by 2, and that is 3. And 18 divided by 6, and that is 3. And 54 divided by 18 is also 3. So you just kind of go through the motions. You're either adding or you're multiplying. So you do the opposite, subtract or divide. Now we get to example 3, and we see we plugged everything in. We see that to get from 1 to 4, we add 3, but to get from 4 to 9, we add 5, and 9 to 16, we add 7. We know we're not multiplying because 1 times 4 would be 4, and 4 times 4 is 16, so that doesn't work. But then when we see that we don't have a constant difference here in this change column. It's staying the same. It's changing every time. It's not the same. So that means it's not linear or exponential because there is no common difference or common ratio. So we can't say that it's one or the other. Now, you try and do the examples on page